Hey, what's up guys, my name is Cherno. Welcome back to my game engine series. So last time we talked about the entity class. Definitely check out that video if you haven't already. Today we're going to be continuing on with the whole entity component system situation, and I specifically want to actually start off with looking through the pull requests that have come in since the last episode, since there are some things to note there. But more or less today I want to take a look at the camera class and just in general talk about how camera systems and all that stuff are going to work in Hazel. So let's do the fancy little, I don't even know if that worked. Did it work? Yeah, it did. Fancy little transition. I finally got a shortcut for that, so I shouldn't be having to click over here and do the fade and do all of that stuff. So what we're looking at over here is Fork, which is my favorite little Git client. And this is just showing us the latest pull requests that have come in since the last episode. So there were some things that I don't really want to talk about. So there's like, some instrumenter fixes, sure, whatever. We don't really use that. At least I don't think that code gets compiled like at all at the moment. This is a really nice change, which I'll probably end up discussing at length in an episode, maybe even of the C++ series, because std bind and std function are not really particularly good things to use. It's a lot better to use a lambda, and that's exactly what this is doing. And it's being a little bit more flexible with that by just, basically doing decal type auto and all that stuff so that we can deduce the return type after the actual lambda is declared and all of that. So we will talk about this stuff in the future. So that's a really good fix by Momo, #Momo. Finally, though, this is what I really wanted to mention, and this is important. So last time I talked about when we actually made the entity class and we did this entity handle, we initialized it with 0. However, what we should have initialized it is null. So if we pop back into the code and take a look at the entity class, then we have, let's see. Yeah, so this used to be initialized with 0. Now, apparently, and I mean, I should have probably done my research. It got to the point where the creator of entity actually told me himself, null is what you're supposed to use, 0 is not what you're supposed to use, because 0 is a valid entity. So in other words, 0 is a valid entity ID. I don't know why I assumed it wasn't, to be honest. I was just kind of like in the heat of the moment, I just decided that it was like 0 would be like no entity. I didn't even know why, because in retrospect I do actually know that it's 0 is valid. But anyway, point is that ent null is what you should use to initialize this entity. If you specifically want it to be nothing, this isn't particularly necessary. I would say if I had to really scrutinize this, which I don't want to do, I don't think it's particularly necessary for this class. Just because, I don't think even though we can create an entity like this, most of the time when we create an entity, it'll be with a handle and a scene. I almost think that it's might be worth deleting this default constructor and not allowing that to happen. The reason why I haven't is because when we create collections of entities like a vector and we resize that vector, it would be nice to just construct it, and we need to initialize it with something if we do that. I mean, we could leave that memory uninitialized. That's another option. I'm not even sure what happens if we just do this. I don't know if that's going to, maybe we should check that out actually. I don't know if I want to take a look at all of this code again though, because it's going to take me half an hour to find out how that actually, what that actually maps to and what that's initialized with the default constructor and all of that. But anyway, regardless of all of that, that's also a debatable thing that we might talk about in the future. Okay. I don't want to spend too much time on this. I've said that 100 times already, and the reason is that this, in general, working with this stuff and talking about all the possible little things that we could do differently is going to be an endless thing, and this video is not even about that. So moral of the story is use ent null for non-valid entities. Okay, cool. So let's do a quick compile and make sure everything builds, because I just did the pull and I'm not sure if everything works. So here we have our green square like last time. And yeah, I mean, everything works, obviously. Good. So basically, I mean, everything would have worked anyway. I just had to make sure the code compiled after pulling the pull requests in. Okay, so now we're getting to the real meat of this episode. And what I actually want to talk about is the whole camera system. So if we go to editor layer, I believe we're rendering everything over here So we have the whole resize system. We might revisit resizing a little bit more just because this was also a pull request and it's probably not done the way that I would do it. And I think I have a better way of doing it. So we might also revisit that. See, this is what happens when you're building this game engine and it's getting complicated. There's just so many things to do. But let's try and stay focused specifically on the camera component. So how a camera is going to work. I also want to probably get rid of Hazel from this entire class because we shouldn't really be using that namespace here. So at the moment, how do our cameras work? I think we just render, so we do begin scene with a camera. That's important. Oh, well, at the moment, we're doing all of our rendering in here. So we probably need to, okay, let's do this because there's so much stuff to do and I'm getting a little bit sidelined here. Let's just make a struct. Let's call it camera component. I'll try and zoom in for all of you people complaining. We'll do camera. I'll just stick a namespace here so it's not ambiguous. And we'll include, so where is this? Hazel renderer camera, right? Orthographic camera. Is that all we have at the moment? What is, I guess we don't have a camera class, do we? No, we just have orthographic camera. This is probably something we should also talk about because at the moment cameras, yeah, okay. And this is specifically an orthographic, okay. Well, we don't support perspective cameras yet. So yeah, this does become a little bit easier than I thought it would be, but that's okay. So this is the core of the camera component, obviously, the actual camera itself. We also have a camera controller, but this is like a camera controller is something that is obviously more of a system. And even though we probably, like, honestly speaking, this is something that I would probably implement within a script, right? So Hazel's camera controller, like for the editor layer, that can definitely be a class and all of that stuff. And also, again, if you're a level editor, you're not a game runtime, you probably wouldn't have a camera component. Like you wouldn't have the editor camera going through a camera component. The camera would be like a, you know, an intrinsic system to the actual editor application. You know, it wouldn't be part of like the ECS. Where the camera is part of the ECS is during runtime. So when we have a game and we are playing that game, then most likely the camera component, or rather there is an entity which is the camera, which has like a transform, which defines where that camera is, and also a camera component, which probably has the camera itself. That's also why this whole situation is a little bit weird, because this has a projection matrix, a view matrix, whereas and a position, you know, and all of that stuff. Whereas technically, none of that's really supposed to be there because you're supposed to take that stuff from the transform. So long story short, camera components are quite complicated in the sense that like implementing, well, okay, quite complicated, meaning they're actually the opposite of complicated. They're really sparse and simple. And I think we will actually make that here. So what we'll do is we'll have a camera. I'll make a new file just to kind of demonstrate how this is going to work. Namespace Hazel. And basically what this camera is going to be is just a projection matrix. So mat for projection matrix. Oh, we'll just call it projection. Will be nice and simple. Okay, so projection, we can set this up. Well, let's just, again, we'll keep this simple. We'll just be able to create one with a projection here. Again, note that there's nothing about this that implies orthographic, perspective, anything like that, right? It can be, at this point, it can be anything. And really the important thing for us is to retrieve the projection. So get projection, const return projection, right? That's kind of it, you know? And again, to keep this even simpler, I think I might just implement it here. That's really all we need for a camera class, because the view matrix, remember the view matrix, what is that? That's the rotation of the, like the orientation of the camera and the actual translation or position of the camera in our world. That's what the view matrix is. And that's not something that comes from within the camera because that's based on its transform. So this is kind of like a runtime camera for a game engine. It's literally this simple. And like the thing is, as we progress, you know, as we'll progress with this series, we'll probably have more functions such as like, you know, set, you know, set perspective, or like set ortho, or set orthographic, or something like that, that will actually modify this projection just with some kind of, just with a cleaner API than having to go through GLM and do all of that stuff. But for now, we'll keep it really simple. So this camera is actually something that I want to have inside the component. So if we go to components, we'll change this to just be a Hazel camera now. We'll include Hazel renderer. I think it wasn't in, I think it's in Hazel camera. Probably should move that to the renderer. In fact, let's do that now before I forget. So where's camera? Camera. Here it is, camera.h, renderer. And again, we'll probably have a CBP file for it in the future, but right now it's this. Let's see, we're including renderer camera now. And I think that's okay. This should work, right? I mean, I didn't move it. I always have to make sure that it actually moves successfully, but I'm sure it did. Yeah, and then this is kind of like, we'll just copy this. You know, we'll take in like a projection so that we can just create a camera component with some kind of projection. To keep it nice and simple, camera projection, camera component. All right, looks pretty good to me. IntelliSense is being a bit upset at me, as usual. Okay, so now that we've done this, again, this becomes pretty easy. We'll go back to edit a layer. We'll make a little, we don't really need to do this technically, but let's do it anyway. Let's make an entity here called camera. Camera entity, and I'm being really explicit here. I'm specifying that it actually is an entity just so that it's easy to read this code. All right, so we'll say camera entity equals active scene, create entity, camera. I'll call it camera entity again, just to be explicit. Camera entity dot add component. So it already has a transform, so we just need to add a camera component to it. And then the camera component will of course take in a orthographic projection. Let's take a look at the one that we were using just because it's most likely right. I mean, we were giving this to camera controller, and I think that was creating something. And obviously, like, this still needs to handle resize events and all of that, so there is a little bit more work to do. And in fact, we did have functions like set projection on the orthographic camera, but that was specifically for, like, that set projection, whereas we probably want set orthographic or set perspective and functions like that. But yeah, okay, I'm not going to care about this. Let's go back to edit a layer and just say that we want to make this an orthographic projection. Ooh. Let's just do 16, 16, negative 9, 9, something like that. And then I guess we'll do near and far as well. Okay, really simple stuff here. Just basically setting it to just an arbitrary 16 by 9 kind of orthographic projection just to see if it works. And that's it. So now our scene actually has a camera. I do want to add one more thing. And this is a little bit of another useful thing to have for a camera, and that is whether or not it's your primary camera. So basically what we want to do, what is going on here? I see this, I hate IntelliSense. Anyway, whether or not it's your primary camera, and again, this is something that is implemented in a wide variety of ways. Like, this could actually be something the scene takes care of instead of it being on the camera component. But basically what this allows you to do is any camera that is set, where primary is actually set to true, and I'm actually contemplating whether or not this is, we'll do it this way for now, and in the future we might change it so the scene is actually, and the system is responsible for this rather than the camera itself. But basically, it's possible to have multiple cameras in your scene, obviously, and you may want to switch between them based on something. So what you can do is only have one camera active at a time, and primary can be set to true. If primary is set to true, then on like multiple cameras, then whatever happens to be the last camera, that's the one that you render through. But obviously there's a lot more, there's many more options that you could actually have with cameras, such as render targets and, like, you know, other complex behaviors potentially. So this is, like, you know, something that you may not want to have on the component, but we'll have it here for now. Maybe I don't know if I should set it to true or false. Obviously if you create multiple cameras, you'll have to set it to false yourself, which might be annoying. So maybe I'll just do this. And then, but this is annoying because now I have to do like, dot primary equals true or something like that, which is weird. So I guess we will set it to true. But yeah, this is like to do, think about moving to scene. Okay, so our camera has, and we don't even have to have that obviously for now, but it's just going to be a little bit annoying to actually see, to find out how we want to render stuff if that's not the case. Okay, so guess what? Now what happens is this. When we want to render, so this is like our render code, render scene, render 2D scene, render 2D. Or this maybe render 2D sprites or something like that. Sprites are 2D, so render whatever. So now that we have a camera in the scene potentially, right, the first thing is actually trying to get it. So we can just do registry dot get, or rather registry dot view. Let's do view camera component. So now we have a view for camera components, and we can actually look at all of them if we want to. So let's do auto entity view, right? And usually I like to scope these up just so I can use like the view variable name for everything. But we'll do this, and let's do, so we definitely have an entity now. We can also do view dot get, let's see, I guess we need the transform. So we'll get the transform as well from here. This will be the transform component of the camera. We might as well just get the transform. Maybe I'm using this wrong. What does get return? Get should get us this component, but I'm not sure if we can do that. Because see, with group you could use get, but with view maybe you can't. I don't know. Obviously I could just do, yeah, sorry. I should be doing, well, actually, I'm not even sure. This will definitely work, registry get, but maybe you can get it from a more narrow point of view. I'm not sure. That wasn't compiling for me for some reason. Or at least IntelliSense doesn't like it. Static assertion failed. Because get on a view, I guess. Entity type is same. So it has to be the same as what? What on earth? Okay. Let's do registry get. So we have transform, we have we also need to get. Okay, this is silly. Let me just double check. Let's try and find the ant documentation, because I'm fairly sure that we should be able to get that stuff. So let's move this here. Now I'm going to be super bright because this is very white. Let's take a look at the entity component system. Where are views? Views and groups. Views. Registry.view, blah, blah, blah. And then in a view. No, you can use view get. Why was that being all sad? Maybe it's because no, I'm not sure if that was the case. So let's go back. Let's do view.get. Maybe let's not do that. Huh. But why is it transform.camera? I'm getting a transform component. I think I understand why. It's because I have to put it in here, don't I? Then what's the difference? Okay. Yeah, so let's take a look at this. Okay, so groups offer a faster alternative to multi-component views, although you can use multi-component views. Okay, well, that's okay. So basically we should use a group. So view is something that you want to use if you're using one component, as far as I understand. And a group is what you want to use if you need to get multiple components. So what we'll do is basically the same as what we did here, right? It's just that we'll get transform and camera. This becomes a group, and we go through the camera component and the transform component. Like that. I guess we can do that, just so that it matches our bottom thing. Okay? There we go. So that should be the best way to do that using ants, although of course, as usual, I am not sure. All right, so at this stage now, let's try and render this. So really the thing that we need to do is find the main camera. So if camera, and this is, I guess we can look at the first one because I guess it shouldn't matter. So this is the camera component. If camera dot primary, then we found the camera. So what do I want to do? Well, most likely, we'll do it here, I guess. Shouldn't really matter. Let's do it up here. So we'll have a camera. We'll try and find the camera. Oops. We'll do this. Main camera. Why does it? What? That's the components. That's why. That's what we want. Okay. So, this is what we'll do. We're basically trying to find the main camera in the scene. If it exists, then we can do rendering, right? So if main camera, then we can render stuff. If not, then there's no point rendering anything because our scene doesn't contain a camera. So if we have a camera now, let's begin rendering. So if we come back to edit a layer for reference, we can see that we have this. We have begin scene. So we can do a begin scene with the main camera, just like that. Except that takes an orthographic camera in, which is a bit annoying. Okay, we'll probably change this API quite a bit, but let's make it take a regular camera in. And we'll add a to-do to remove the Hazel renderer camera. But the thing is, and this is where it gets really interesting. We most likely, like when you actually render though, you need to know the transform. So is it like, do we really want to then create like a mat4 that is the transform, which is like the view matrix? Probably not. So because of that, we're actually going to do something else. This camera is essentially a camera component, right? And we might refactor the names a little bit here. But what we want to actually have is a renderable camera. And a renderer kind of camera is a camera that has a projection and a view matrix, because we definitely need both of those. Whereas this is more or less like, I don't know how to say it. This is more or less like the camera component kind of, because it doesn't include the transform, it doesn't include the view matrix, because that lies in another component. And obviously we want it to work with another component. So yeah, we ultimately have this kind of problem here where we might want to have just this camera inside a component. And obviously, like, you could argue that, well, you know what, why don't you just go to components and just have a GLM mat4 here, which is your transform, which is your projection, right? You could do that, but the problem is you lose a lot of, like, you lose the actual camera, right? A lot of the stuff that the camera class provides, such as like get projection or like, set perspective with certain parameters, you lose all of that, and it's nice to have that functionality. So that's why, like, it's a little bit annoying. And you could put that functionality on camera component, but as a component, it's not really supposed to have functionality like that. So ultimately speaking, I think what I'll do is we'll have camera, but then also what I want to do is each renderer potentially, and this is probably going to be shared between the 3D renderer and the 2D renderer, so it's a bit annoying. But ultimately, this might have a struct called camera, right? And this specific camera struct, and we can call this like render camera or something like that, I don't know. This will have and you know, this is just one way of doing this that I'm showing you. Not sure if I will stick to this either, but we have a projection and we have a view matrix. Now, the reason this isn't great, potentially, is because if you have to construct this every time you begin scene, which isn't that often, so it's probably okay, you need to copy the matrix here. Type punning your way into this is probably not a good way to go, especially because you're not going to have enough room for the view. But, you know, that's ultimately, it's one way that you could look at this. You could begin a scene with a camera and then some kind of view matrix, and then that way, the API would look something like this, where you could basically just go back to scene and just say begin scene, you know, here's my main camera get projection, and then here's my transform, right? Which we also need to save, by the way. And then that way you begin it like that. That's something that you could do, you know? I've seen that as well. But what we'll do, I think, is we will take in a camera like this, but I think the best way right now is also to try and take in a transform. So we have a camera and we have the camera's transform. This is not a view matrix, it is the camera's transform. So we have to invert it, but that's what we have, okay? So we'll just do it this way, and let's create an implementation for it. We'll do it this way, and this will be largely the same as this. You know, we set the view projection here, so we'll have to set that up. We do some texture binding here. You know, again, we will remove this stuff, so let's copy it for now. And then what we'll do is we basically need to get the, so glm mat4 view proj equals camera.getProjection times glm inverse transform. All right, this should give us the camera's view projection matrix, or the projection view matrix technically. All right, and then we can set that. That's it. So back in scene, instead of doing all this, we just do this. And we have a glm mat4 transform. Let's see. Thank you for the arrow, which no one asked for. Okay, and then transform. This is upset again. What's the transform component? That has the transform in it, which is a mat4. So why are you upset? What type is this? It's a mat4. What's transform? Ah, sorry. I just, I'm reusing variable names. And of course, transform is dumb. I don't know why I decided to call it like that. Camera transform. Okay, so we've got the transform, we've got the camera. Now we can actually pass that in here and we should be good to go. So now we can begin a scene with our main camera, and then we'll do end scene as well. Render a 2D end scene. And then obviously in between that, we render all of our stuff. And if there's no main camera, we don't need to render anything. Okay, so there we go. We should now be able to render everything if we have a main camera. So render 2D. We'll just do render 2D. All right, cool. So let's test this out. Let me just make sure that, I guess we probably won't render anything here. So let's get rid of begin scene. So that used to be camera control. Okay, so we won't be able to control the camera obviously, but now you can see all we have here is render command, set clear color, clear, and then we just do on update, and that's it. So hopefully this will work. All right, and we see our, and 16:9 wasn't the best choice here because this isn't 16:9, but you can see now we actually have our green square and it's being rendered by a camera that is obviously our camera component. If we don't create the camera component, so I'll go ahead and not do the camera entity, then it should still work, but we'll just see like a dark gray screen with nothing rendering, I guess, because there's no camera. There we go. Pretty simple. And I guess that's it. So that's our camera situation. Again, there's a lot of different ways to do this. I want to stress that. I don't particularly like all of the ways, like everything about the approach that I've chosen. If you guys have other suggestions, you can leave a comment below. I don't think there's any real big problems with this. It will get a little bit different when we start dealing with different render passes, rendering to textures, stuff like that. But ultimately, this is more or less like a main camera system. So if we have a camera that is marked as the primary camera, then that's what it will be like. As a little quick test though, what we could do is create multiple cameras. So let's do this as well. We'll do second camera. Second camera will basically be the same as this, except let's make it a little bit more zoomed in. Or maybe let's adjust this transform. I completely forgot about the camera's transform. Let's do this. Second camera, whoops, hit something there. Let's do like, we'll make it like -1, 1, -1, 1. So it's like a little clips-based camera. Clips-based camera, sure. And then let's go back to I am GUI. Man, the font is so large, it's so hard to read. Let's do, so if we have, like, I don't need to do that. Let's just do camera entity. So we'll adjust the first camera's transform. I don't even know if we can do that well. I guess we can try. Yeah, this is not going to be pretty. Let's get that. Okay, let's do this. Let's do this. I am GUI float drag float 3 camera transform GLM value pointer that. So we're getting the last column of the matrix here, and then feeding that in as a pointer. Min and max, so speed 1 is fine, min and max is, yeah, okay, we can just leave that as is. All right, and then we should now be able to move that camera, okay? And also we want to switch between the cameras, so let's do this as well. We'll do a quick way. Primary camera equals false. So this is just a little switch. Honestly, we're just going to display it as a checkbox. So checkbox, label camera A. I don't know. And we'll make this the primary camera. If that changes, I basically want to, so let's probably initialize this to true. And then let's maybe come over here to the second camera. We have a camera component here, auto camera component, CC. CC.primary equals false. So it's false by default, and then we'll just say that m second camera dot get component camera component dot primary equals not primary camera, and then primary camera, and we do the same thing. Sorry, it's called camera entity, isn't it? Okay, we'll flip that. So basically it will be like, you know, if we've got, I think if I've done that right, if we check the checkbox, we should be seeing our primary camera, which is the one whose transform we can move. If not, we'll be seeing the other camera, depending on what we actually check or not. So let's take a look at this. We get a nice little crash here. Render API clear crashed. That's weird. Out of all the things I would have expected this code to do, that was not one of them. What on earth happened there? Did I do something? Let's just hit a file again. That was weird. Something to do with our frame buffer. Huh. Let's see what's happening here. What did I do? What did I do since the last time I ran it? I added an entity, which should be doing nothing. That almost seems like, and it looks like it's in a different place every time. What an interesting problem. So what's actually, where's my output? What's actually happening? Critical error detected. Oh no. Critical error detected. So this, I mean, it suspiciously seems to be happening in the OpenGL driver. This could be like some kind of weird heap corruption or something like that. What could I have done? Let's do a rebuild. I'm out of ideas. Now it works. Oh man. Okay, weird. It seems to work now. So I did a rebuild and it works. So let's roll with it. Okay, so we have this square, obviously. We have the camera's transform, as you can see over here, right? So we should be able to actually move this, and you can see that it does work. If we move the camera to the left, so we're going negative here on the x-axis, it's obviously moving the camera to the left because the square's moving right. Same with up and down, and like Z, like that's not going to really do anything because it's just going to, it's an orthographic camera, so we won't see it getting smaller. Okay, so that's that. And we are rendering with camera A now. If we uncheck this, we should be back to the clip space camera, which is camera B. And of course we can like move this somewhere else and this camera will always remain here. Okay, so now you can see we've got multiple cameras. We can render with both of them. And that is how you set up a little camera system in the entity component system. Anyway, thank you guys for watching. Hope you enjoyed this video. If you did, please don't forget to hit the like button. You can also help support the series by going to patreon.com/thecherno and getting access to Hazel Dev Code, as well as weekly live streams where I develop all the code. So if you want to see like a camera system actually implemented or anything really that we cover here, but in a lot more depth, and you thirst for more Game Engine series episodes, then do check that out because the weekly live streams, I think, are a really good time. And by the way, this episode was entirely streamed live on twitch.tv/thecherno, something I'm playing around with. So if you're interested in that, definitely check out the link in the description. I didn't really announce it anywhere apart from Twitter, so you can also follow me there if you want to catch the next stream. Anyway, I'll see you guys next time. Goodbye.